Welcome back to Math with Rhyme or Reason. Today I'm going to continue the series on radical math. We're going to do adding and subtracting. Remember when you're adding and subtracting radicals that you can only add and subtract like radicals. So they have to be the same jail, that is square root or cube root, and the same number within jail. For example, if we start with something simple like 3 root 2 minus 5 root 2, you're just counting root 2's. So if I have 3 root 2's minus 5 root 2's, then I have negative 2 root 2's. So just like terms, you don't change what it is you're counting. This doesn't become root 4, or you don't subtract the root 2's and get 0, or things like that, okay? You're counting root 2's. I got 3 of them, minus 5 of them is negative 2 of them. Now sometimes, in fact, most likely, they try to fool you with their questions by making your radicals look unlike when they're actually like. For example, if I had negative 3 root 12, for example, and I added 4 root 75. All right, they're both square roots, but the number under the radical sign here is a 12, and the one under the radical sign there is a 75. But if we simplify them, that is jailbreak our radicals first, then I think they'll be like. Let me show you what I mean. So if we simplify root 12 by prime factorizing, so that's 2 times 2 times 3, and root 75, which is 5 times 5 times 3, all right, and then we jailbreak each of them. So in the first one, 2 gets out, and he'll multiply by the negative 3 here in a minute, and the 3 will be left in jail. On the second one, the 5 gets out. We'll multiply him by the 4 in a minute. This one doesn't make it, and the 3 is left in jail. So now we have 2 times negative 3, which is negative 6. Root 3, because the root 3 is still in jail. 5 times 4, which is 20. And that's also root 3, still in jail. Now they're like. Negative 6 root 3 plus 20 root 3 is 14 root 3. Now this also works if they have the same jail, but it's high security jail. So for example, let's go back to the first example that I did. And instead of having square roots, we'll do cube roots. So if I had 3 cube root 2 minus 5 cube root 2, again, I'm counting cube root 2's. So if I have 3 minus 5, that'll be negative 2 cube root 2's. Just a note, when you're writing these in your homework or on a quiz or test, be really intentional about where you put the cube root. You don't want this to be read as 3 cubed square root 2. You want it to be read as 3 cube root 2. So make sure that your little 3 is attached to the jail and there's enough room in there that it doesn't look like you've cubed the 3. Okay? So if we choose another example, I'm going to do that one, which is 4 cube root 16 minus 3 cube root 54. Okay, again, they don't look like yet. So let's simplify both and then see where we go. So I'm going to prime factorize my 16, which is 4 2's. I'm going to prime factorize my 54, which is 27 times 2. So that's 3 3's and a 2. Right? And then I'm going to look to see who can get out of jail. So a 2 can get out here. These 2 don't make it, and this guy is still left in jail. I can get a 3 out here, and the 2 is still left in jail. So remember the 2 and the 4 are now going to multiply. So that'll be 8 cube root 2. Oh, that looks like I've cubed my 8. I'm just going to make that a bit clearer. Minus 3. Oh, sorry, I forgot to multiply. The 3 comes out times the 3 will be 9. And cube root 2. So I have 8 cube root 2 minus 9 cube root 2 is negative 1 cube root 2. And again, the negative 1 part is optional whether you write that or not. You can just write it as negative cube root 2. All right. This also works again with variables. So when you have variables, you got to make sure still that your jail is the same and that whatever is in jail is the same. So for example, just going to steal the example from here. There it is, 3x root 63y. Oh, let's do a plus this time. 5 root 28x squared y. 5 root 28 x squared y. Okay. So they're both square roots. I'm going to simplify both radicals and see if we can make them look alike. So I'm going to prime factorize 63, which is 9 times 7. 9, of course, is 3 times 3 times 7. 28 is 7 times 4. So that would be 2 times 2 times 7. And I'm going to write the x's and y's out as well, just so that we're really clear about what's going on. All right, now I'm going to break anybody out of jail that I can. So in the first radical, I can get the 3 out. The 7 and the y are both stuck in jail. On the second radical, I can get the 2 out, and I can get the x out. And the 7 and the y are both in jail. So again, I'm going to multiply the 3 times the 3 that's already out of jail, so that'll be 9x root 7y, plus the 5 times the 2 times the x will be 10x root 7y. Now with variables too, you have to make sure that even the ones outside have the same like terms. That is, this can't be an x squared, for example. So this is an x square root 7y. This is an x square root 7y. I've got 9 of these. I've got 10 of these. So I have 19x root 7y's. Be really careful when you're combining your like terms that you don't change what it is you're counting. You're counting x root 7y's. I've got 9 of them. I've got 10 of them. That's 19x root 7y's. Okay, so, and on the next one, I will be doing what happens when you get more complicated multiplications, that is, if they're in different jails, and what happens with dividing, as in you have some things in the denominator. So join me soon on the next version of the multiplying and dividing of radical math. See you soon.